At the end of part 1, we thought about how to make an orange color twice as bright. I suggested that you might want to type something like this, where we simply multiply a color variable, here OC, by 2, and store it in a new color variable, NC. So that should make the color twice as bright, right? I noted that processing will let you type this, but I wish it didn't, because it will almost never do what you want. Well, let's try it and see what happens. Here's a little program to do just what we saw. I begin by calling void setup, size and smooth. I define an orange color. It's in fact the very same orange we used in the last example. I fill with the orange, and then I draw a rectangle. And then I fill with 2 times orange and get a rectangle. So we would expect this rectangle to be twice as bright as the one on the left, right? Well, let's run it. That does not look like a bright orange to me. In fact, there's almost no way that you're going to make sense of this in general. That you'll be able to come up with a system where doubling orange gives you kind of a pea green color. It's just never what you want. Happily, we already have the tools to do this the right way. So this is the way we just tried, and we know it's the wrong way. What's the right way? The right way is to take the color and pull it apart into its pieces. And we know how to do that. We call red, green, and blue on it, and that gives us 3 new floats. The code for that is really simple. Now I'm going to create 3 new floats called new red, new green, new blue, and those are just going to be double the old ones. I'm just taking whatever number we got for red, green, and blue, and I'm doubling it. The code for that is perfectly easy. New red is just 2 times old red. It's simply what's in the middle white boxes. And then we mash those things together to make a new color using color. The result is a doubly bright color. The code to create new color is just what's in the white box. So let's go ahead and do this in the code we just saw. So here's the new program, and it's nothing more than what we just saw. I inserted 3 lines to compute the red, green, and blue values of the orange color and store those in floats. Then I have 3 new floats that just have double the values of the old ones. I create a new color called bright orange, and I fill with bright orange. And if we run this program, we get a brighter orange and not some weird murky green color. So this is the way you would modify a color. And this is the standard technique. Anytime you have a color, pull it apart into its red, green, blue, do something with the red, green, blue, and now make a new color. So let me show you another example of using this technique of pulling things apart and putting them together to manipulate a color. Suppose we want to add 2 colors. So we start with color 1 and color 2, and we want to create new color. And I hope you know by now, this is not the way to do it. New color equals color 1 plus color 2. You can type this and processing will run it for you, but oh boy, you're going to get screwy results. Let's take a look. Here's a program very like the last one. I have void setup, size and smooth. I create 2 colors, the color of a nice green lawn and the color of some rusty metal. So it's sort of a greenish and an orangish. First I fill with the green one and I draw a rectangle. I fill with the orange one and I draw a rectangle just so we can see them side by side. Then I create a new color, which I'm calling add color. And it's just lawn color plus rust color. I fill with the new color and draw a rectangle. So think about it for a second. What should a greenish plus a reddish look like? It should probably be a yellowish because we know red and green light combine to make yellow. So let's go ahead and run it. And that's about as far from a yellowish color as one can get. It's just completely wrong. There's just no reasonable way that green plus kind of this orange rust color should come out to be this rich blue. And it's because adding colors, doing any kind of arithmetic on colors, is just screwy. Again, we have all the tools we need to do this right. We know that this is not the right way. The right way is to take the first and second colors that we're going to work with, and to build the new color, the first step is take the first color apart into its pieces using red, green, and blue on C1. That will give us these 3 floats. We do the same thing on C2. We get 3 floats. And now we add the floats together. So to create a new red, I just add red 1 and red 2. And that gives me the new red value. Similarly for the green, I just add together the green values. And the blue, I add together the blue values. From these 3 floats, I compute a new color by calling color with new red, new green, new blue. That gives me a new color, and now this one is the sum of color 1 and color 2. Writing the code for this is really easy. For example, to compute R1, we just say R1 equals red of C1. The green and blue of C1 are the same thing. So these 3 lines on the right do all the work in the upper left corner of the diagram. Well, we do the very same thing to compute R2, G2, and B2. We just call red, green, and blue on color 2. And then we can create the new color red by adding red 1 plus red 2. So these lines are the actual processing code. There's nothing more to it than implementing, the picture in the diagram. We compute new green and new blue, and then we compute the new color by calling color on new red, new green, new blue. Let's go back to our example and do this and see the result. Here's the new program. I've taken out a few of the vertical spaces so everything would fit on one screen in this very large font. All the stuff up here is identical to the last time. Now I do what we just saw in the diagram. I find the red, green, and blue values of the first color, in this case lawn color, and stick them in floats. I get the red, green, blue values of the second color, in this case rust color, put them into floats. I find their sums and put those into floats. And then I find a new color from the new RGB values. These last 2 lines are the same as before. I fill with the new color and draw a rectangle. So now let's see what happens if we add a reddish and a greenish color with the proper addition. And it's great. A greenish plus a reddish equals a yellowish. And this is exactly what we would expect. So this is the general technique. So now you can see how to manipulate color variables. We can make them, we can pull them apart, and we can do whatever we want to one or more of them by pulling them apart and putting them back together again. Once you get the hang of using color variables, you will never go back, and you're going to love them.